Hey, so on Tuesday we talked about lesson 8.1, which was on multiplying and dividing rational expressions. Today we're going to be moving on to lesson 2, and we're going to be talking about adding and subtracting those rational expressions. Now, if you remember, a rational expression is a ratio. It's like a fraction, except that it has a variable in either the numerator or the denominator or both. So just like adding and subtracting fractions, when we're adding and subtracting rational expressions, we need to come up with a common denominator. So the first thing we're going to talk about here, in order to start learning how to come up with our common denominator, is, we're going to talk about how to find the least common multiple first of two monomials, or two or more monomials. So finding the least common multiple of each set. So what we want to do in order to find the least common multiple of a set of monomials is first, I'm going to write each of my monomials vertically here. And again, just a reminder, the least common multiple is the smallest number or the smallest monomial that each of these three will factor into. So the first thing we want to do is write out the prime factorization of each of these monomials. So for 18, you can think of these as doing number trees. For 18, we can go 6 times 3. 6 becomes 2 times 3. So 18 would be 2 times 3 times 3. Instead of writing that out as 2 times 3 times 3, I'm going to say 2 times 3 squared. Then I'm going to leave the variables with their powers. So 18 r squared s to the 5th becomes 2 times 3 squared times r squared times s to the 5th. Then for 24, again, we can do a factor tree here. Let's go 6 times 4. 6 becomes 2 times 3. 4 becomes 2 times 2. So since we have 3 2's here, this would become 2 cubed times 3 times r cubed times s times t squared. Then 15 is 3 times 5 times s cubed times t. So now what we want to do is we want to go through and we want to find each factor when it is used the most times, or in other words, each factor to the highest power. So we know that 2 is a factor. It shows up as 2 to the first power and 2 cubed. 2 cubed has a higher power than 2 to the first, so we're going to use 2 cubed. We're going to cross out the 2 to the first power. Let's move on to 3. We've got 3 to the first, 3 to the first, and 3 squared. So we're going to use the one with the highest power, cross out our other 2. 5 only shows up as 5 to the first, so that's the greatest power. For r, we've got r squared and r cubed, so we're going to use r cubed. The highest power of s is s to the 5th, and the highest power of t is t squared. So now that we have done that, we're going to multiply each of those powers that we came up with. So 2 cubed times 3 squared times 5 times r cubed times s to the 5th times t squared. So when I multiply all of those together, I would get 2 cubed, which is 8, times 3 squared, which is 9, times 5. So that comes out to 360 r cubed s to the 5th t squared, and that would be the least common multiple of those 3 monomials. So again, that's the smallest monomial that all 3 of these can go into. Let's do another one of these. I just want to really make sure you guys are getting this, because In order to move on in this lesson, we really have to understand this concept of coming up with the least common multiple. So for the second one, I've got 12a squared b to the fourth, 27ac cubed, and 18a to the fifth b squared c. So the prime factorization of these, for 12, I can break it down to 3 times 4. 4 is 2 squared. So 2 squared times 3 times a squared times b to the fourth. 27 is 9 times 3. 9 is 3 squared. 3 squared times 3 gives me 3 cubed times a times c cubed. 18, I would get 2 times 9. Again, I know that 9 is 3 squared, so I can say 2 times 3 squared times a to the fifth times b squared times c. And then again, I'm going to go through and find each factor to the highest power. So for 2, the highest power is squared. I've got a 3 in each of them, but the highest power is cubed, so that's the one I'm going to use. Highest power for a is to the 5th power, b is to the 4th power, and c is cubed. So for my least common multiple here, I would have 2 squared times 3 cubed times a to the 5th times b to the 4th times c cubed. So this would be 4 times 27, which gives me 108, a to the 5th, b to the 4th, c cubed. So that is, I've done 2 of them. You can go back, look over those if you need to. If you're really not understanding this, there are other resources out there you can look at. You can get a hold of me. We can walk through some more together. But that's 2 of them. You can always go back and look at those examples again to make sure you really understand what we're doing before we move forward. So that was with monomials, meaning there's only one term. Next, we're going to find the least common multiple for a set of polynomials, meaning that there is more than one term. So in order to do this, in order to find the least common multiple for a set of polynomials, what we want to do is get it factored down to its simplest form. So for our first one, p cubed plus 5p squared plus 6p. The first thing we can do is go ahead and factor a p out of each of those terms. Leaves us with p squared plus 5p plus 6. And then we can factor this polynomial. We need 2 numbers that multiply to 6 and add to 5. That's going to be 3 and 2. So p plus 2 and p plus 3. So this is the factored form of this first polynomial. The second one, 2 numbers that multiply to 9 and add to 6 would be 3 and 3. So I'm actually going to erase this second set of parentheses and write this as p plus 3 squared. Or actually, just to not confuse anybody, p plus 3 times p plus 3, which we can then write as p plus 3 squared. Just like on that last slide, where if a term was used more than once in one monomial, we wrote it as 3 squared instead of 3 times 3. You would do the same thing here. Instead of p plus 3 times p plus 3, you would use p plus 3 squared. So those are the factored forms of our 2 polynomials. Then we're going to go and do the same thing. We are going to use each factor the greatest number of times that it's used. So in this case, we have p to the 1st power. That's the only time that p is used by itself. We've got a factor of p plus 2. That's the only time that that's used. Then we've got p plus 3 and p plus 3 squared. Since this one, it has a higher power, we're going to use that p plus 3 term and get rid of this one, then we multiply those together. So p times p plus 2 times p plus 3 squared. We don't actually have to FOIL them, distribute that p. You would write your final answer in this form with the factors. Let's do another one of these here. So I'm going to go ahead and do my first one, q squared minus 4q plus 4. So in this case, I need two numbers that multiply to positive 4 and add to negative 4. Those two numbers are going to be negative 2 and negative 2. So just like that last one, I'm going to write this as q minus 2 squared. Then for my second one, first thing I can do is factor a q out, which leaves me with q squared minus 3q plus 2. Then I need to factor that polynomial. So I need two numbers that multiply to positive 2 and add to negative 3. Those two numbers would be negative 2 and negative 1 in this case. So now I need to figure out each factor used the most times, or with the highest power. So q is only used there, q minus 1 is only there. I've got q minus 2 and q minus 2 squared. So I'm going to use the q minus 2 squared since it has a higher power. My least common multiple would be q times q minus 1 times q minus 2 squared. So that's finding the least common multiple. The next couple slides now are going to be some examples of when we will use those. So now we're actually getting into adding and subtracting our rational expressions here. So 7x over 15y squared plus y over 18xy. Since these are fractions, we know we need to have a common denominator. So in order to come up with that common denominator, I'm going to do what we did of finding the least common multiple between my two denominators. So 15y squared and 18xy. 15y squared I can write as 3 times 5 times y squared. 18 I can write as 2 times 3 squared times x times y. Then, just like I did before, I want to use each term to its highest power. So I'm going to use the 2, the 3 squared, 5x, and y squared. Multiply those terms together. And that gives me my least common multiple, or in this case, we can call it my common denominator, of 2 times 9 times 5, which gives me 90, and then x, y squared. So we have our common denominator now. Now we need to figure out, what do we need to multiply 15y squared by to get to 90xy squared? Well, 15 goes into 90 6 times, so we need to multiply by 6, and then we also need an x in there. Anything we do to the denominator, we have to do to the numerator. And then same thing on the other side. What do we need to multiply 18xy by to get to 90xy squared? From 18 to 90, we need to multiply by 5. We've already got the x. We need to get y to y squared. So we're going to multiply by 5y. So this will now become 6x times 7x. Gives us 42x squared. Then we've got our common denominator of 90xy squared plus y times 5y gives me 5y squared over 90xy squared. Then I'm going to write it with just our common denominator on the bottom. It's going to be one term now. So 90xy squared in the denominator in the numerator, I've got 42x squared plus 5y squared. That can't be simplified anymore, so that would be our simplified version of the expression. Let's go ahead and do another one. I'm going to skip this step on the next one and just kind of do that in my head. So here, I need to come up with my common denominator, or my least common multiple, between 3xy and 5y. So my common denominator, the smallest number that 3 and 5 both go into. In this case, that's going to be 15. Then I just want to look at my variables and use each one to its highest power. So x, its highest power is 1. Highest power of y is also 1. So now we're going to take those same steps. In order to get from 3xy to 15xy, we need to multiply by 5. Again, whatever you do to the denominator, you have to do to the numerator. Then on the right side, to get from 5y to 15xy, we need to multiply by 3x. So this will now give us 10 over 15xy minus 3x squared over 15xy, which we can then combine, not 3x squared. 3x times 3x gives us 9x squared, which we can then combine to one term, which would be 10 minus 9x squared over 15xy. Let's walk through one more of these. 6c over 7b squared plus 2d over 3ab. So again, I'm going to come up with my common denominator. The smallest number that 7 and 3 both go into is going to be 21. Then the highest power of a is to the first power. Highest power of b is squared. So to get from 7b squared to 21ab squared, we need to multiply by 3a. To get from 3ab to 21ab squared, we need to multiply by 7b. Now this one, I'm actually going to go ahead and take out this middle step of writing it as two different terms and then simplifying down to one. I'm going to go straight to one term now, because I know my denominator is going to be, as long as I figured multiplied by the right numbers, I'm going to have that common denominator of 21ab squared. Then in my numerator, 3a times 6c gives me 18ac plus 2d times 7b gives me 14bd. And that would be our simplified expression. So that was with monomials in the denominator. Next, we're going to work with polynomials in our denominator. So when we have polynomials in the denominator, we want to start, just like we did before, of finding that least common multiple to give us our common denominator. So in this case, what we're going to start by doing is rewriting the original problem, but with everything factored as much as possible. So the first one will be w plus 12. We can factor a 4 out, so 4 times w minus 4 minus w minus 4 over, we can factor a 2 out here, and we're left with w minus 4 again. So now using that, we want to take our two denominators and come up with our common denominator. Now, the number outside, that constant, the smallest number that 2 and 4 both go into is 4. Then w minus 4, the highest power it has as a factor, is the first power. So our common denominator will be 4 times w minus 4. Now on the left, we've already got that, so we don't have to multiply by anything. The right term, in order to get a 4 outside the parentheses, we need to multiply by 2, numerator and denominator. So then, again, I know that I'm going to come up with that common denominator of 4 times w minus 4. In my numerator, I'm going to end up getting w plus 12 minus, in this case, I'm going to distribute my 2 into the w minus 4. So minus 2w minus 4. So then I need to combine my like terms, and I'm going to have, wait, sorry, nope, not minus 4. Trying to move too quickly through this. 2 times 4 gives me 8. So combine my like terms, w minus 2w will give me negative w. 12 minus 8 gives me a positive 4, and that's all over my common denominator of 4 times w minus 4. And that would be my simplified version of this expression. Come on. Let's go ahead and walk through one more of these. Again, first step, I'm going to write my original problem with everything factored as much as possible. So x plus 6 over, I can factor a 6 out of my denominator, which leaves me with x minus 3. And I'm going to add x minus 6 over, I can factor a 2 out, and that leaves me with x minus 3. So my common denominator here, the smallest number that 2 and 6 both go into is 6. And I've got a factor of x minus 3. Its highest power is to the first power. So my left side already has my denominator that I need. My right side, I need to go ahead and multiply by 3 in order to get that common denominator. So I'm going to have a denominator of 6 times x minus 3. Then I'm going to have x plus 6 plus 3x minus 18 once I distribute that 3. Again, combine my like terms. X plus 3x gives me 4x. 6 minus 18 gives me negative 12. And that's all going to be over 6 times x minus 3. But now there's actually one more step that I can take here. If I look at this, 4x minus 12, I can factor a 4 out of that, which gives me 4 times x minus 3 over 6 times x minus 3. Now, I can cancel my x minus 3's. I'm left with 4 over 6, which simplifies to 2 over 3. So what we started with up here simplifies all the way down to a fraction of 2/3. We've got 2 more slides here, a couple problems on each slide. The first one, simplifying complex fractions. So we talked about complex fractions on Tuesday, where it's a fraction that has a fraction within it. So here, we're going to have rational expressions adding and subtracting within our complex fraction. So here, we've got 1 over x minus 1 over y over, or divided by, 1 plus 1 over x. So the first thing we need to do is come up with common denominators here. I'm going to go ahead and change this 1 to make it 1 over 1, so we've got all fractions that we're working with. So here, in our top rational expression, in our numerator, our common denominator is going to be x times y. So on my left side, I need to multiply by y. On my right side, I need to multiply by x. In my rational expression in the denominator, between 1 and x, my common denominator will be x. So I just need to multiply the left side by x. So now this is going to be rewritten as my numerator. I've got y over xy minus x over xy. And that is going to be over or divided by x over x plus 1 over x. Which now I can combine my terms since I have common denominators. So in my numerator, I've got y minus x over xy over my denominator of x plus 1 over x. So now we're down to what we did on Tuesday. We've got a complex fraction. Really, it's just division. So when we divide fractions, we're going to take y minus x over xy, and we're going to multiply it by the reciprocal of the denominator, which is going to be x over x plus 1. So now I can go ahead and simplify anything diagonally, which here I can get rid of my x's. Those will cancel each other out. I can't cancel anything out here. So now when I multiply straight across, I will get y minus x over y times x plus 1. And that'll be my solution there. Let's do one more of these. So here, I'm going to look at just my numerator first. So I'm going to ignore everything here. I've got 1 over x plus 1 over y. The common denominator there will be x times y. So I need to multiply by y on the left and by x on the right. Now my denominator, 1 over y minus 1 over x. Again, my common denominator is going to be xy. So I multiply the left by x, multiply the right by y. This will now become y over xy plus x over xy all over x over xy minus y over xy, which then I can combine the numerator and denominator each into one term. So I'll have the numerator, which is y plus x over xy, have my denominator, which is x minus y over xy. Then, just like I did before, I'm going to rewrite this division problem as a multiplication problem. So I'm now going to have y plus x over xy times xy over x minus y, which I can cancel my xy, and I'm going to get y plus x over x minus y. And that'll be my solution. So the last slide here, we're going to go through a problem of solving a problem using what we just learned. So find the slope of the line that passes through each pair of points. We have one point that's at 2 over p 1/2. So 2 over p is our x term. We'll call that x1. 1/2 will be our y1. Second point has an x2 of 1/3 and a y2 of 3 over p. Now if you remember, the slope of a line, m, is equal to the rise over the run, so y2 minus y1 over x2 minus x1. So I want to go ahead and set up, it's going to end up being a complex fraction in order to solve for my missing value of p here. So my slope is going to be equal to y2, which is 3 over p, minus y1, which is 1/2, over x2, which is 1/3, minus x1, which is 2 over p. Now, in my numerator, my common denominator is going to be the smallest number they both go into is 2. Variable is p, so common denominator will be 2p. So I'm going to multiply by 2 on the left and by p on the right. Denominator, the common denominator will be 3 times p. So multiply by p over here, 3 on the right, and this will now become 6 over 6 over 2p minus p over 2p over p over 3p minus 6 over 3p. Then I can make one term in the numerator, one term in the denominator. I'll have 6 minus p over 2p over, does this even when you guys aren't here, p minus 6 over 3p. Now I want to turn this into multiplication. So I'm going to have 6 minus p over 2p times 3p over p minus 6. Now, if you remember, in the last lesson, we learned about factoring out a -1 to be able to change the order of a term. So I've got a 6 minus p and a p minus 6. I can turn this 6 minus p into p minus 6 by factoring out a -1. Again, if I take 6 minus p, I take a -1 out of that, it leaves me with -6 plus p, which really, I can change the order of this to be -1 times p minus 6. So I'm going to go ahead and get rid of that and make it -1 times p minus 6, because then I can cancel out my p minus 6, I can cancel out my p, and I'm left with -1 times 3, which gives me -3 over 2. So our missing value would be -3 over 2. So that's using what we did on the last slide, the simplifying complex fractions, and putting it into being able to solve a problem using that. So I know this is a lot of new stuff. It builds a lot off of what we've been doing, and it is a little bit harder of an assignment. But there is your assignment. This is going to be, I'm going to change up a little bit. So this is a 2-through week, so we are going to have another lesson on Friday, but what I'm going to do is I'm going to make today's lesson and Friday's lesson both due on Tuesday. So that way you don't have to worry about having to crank all of this out. It's going to give you a little bit of extra time. The due date will be changed on Google Classroom as well. So again, this lesson and the lesson we're going to do on Friday will both be due on Tuesday. Please make sure you're getting on Google Classroom. There's still a few of you that haven't done that yet, which shows me that you're falling behind in the class, and we really want to make sure you guys are staying caught up. So please get signed up on there and be reaching out if you need any help on anything.